We were late. Thank you, Okot Ice Cube, for joining. So I've already shared my screen. Let me go to the book. I'm already at the book. I want to see what we did last time. So last time we did module stack likeness and method lookup. Today we're going to do an object's eye view of method lookup. That is where an object's eye view of method lookup. We're still not yet at method missing basics. Yeah, stack likeness, modules into a class, using the module further, module classes, method lookup. Here we are. So this is where we have to start today. What else do I need to do? Let me lock my screen because it will start disturbing to me. Awesome. All right, Kevin, you can take over.
Fungue kontami ama answer. Hello. So, have I shared the screen? It's shared. Okay. So, today we'll be looking at an object eye view of method lookup. So, this just means that when I have, for example, when I have a class, let me say class A. Oh, sis, nini? Unasikika huku?
Hello. Yeah.
Huh? Let me see. Hebu. Oh, lazima utoe. Hebu. Usitoe, rudia.
Hello.
Oh, if you're talking, you have to remove this.
No, I'm still
And
being hard. But this holds.
bado.
Just carry on.
Okay, unasikika but kidogo. Ama ni juu nimeacha hii. Juu vile uko karibu ama? Okay, so let's begin. So I was saying what an object's eye view of the method lookup. So I was trying to, let me go to, I love Prime. I have a thing with Prime. Okay. So assuming I have a class that and I have a method icebreaker, then I put this.
I've used the holds correctly. Yeah, yeah.
Okay, so assuming I have this class here, yeah. So just a minute.
Iko wapi ni settings? Na sai?
Hello.
Sai? Bado nasikika?
Yes.
Na sai?
Still. Bado tunasikika.
Okay. Eh?
Hello. Yeah.
Iko sawa?
Bado tunasikika.
But kidogo ama
Mob.
mob. Hata wao.
Mm.
Ai. Oh, ama ni lap yako. Okay. So assuming I have this class, then if I create an instance of the class A, and then I call a method icebreaker. So method lookup is just how it's like how this line, how the backtracking in this case will happen. For example, like for this, Ruby will first check for this A. What is it? Have we defined it somewhere? Then it finds, oh, it's an instance of a class. Yeah. So if it's an instance of a class, then what you are following here is a method. Yeah, is an instance method. So in method lookup, we are just backtracking to find where this is, and if we find it, then we'll execute it. If we don't find it, we'll run. You will find some error. Like in this case, what will happen is, if we call this, if it has confirmed after confirming A is an instance of a class, that's okay. Then we have now the method icebreaker. So what will happen in this case is it will first confirm, oh, is icebreaker is the instance A, is it able to respond to this method? Or first what will happen is actually it will go to the class A. So the control flow will come in here. First thing is search if this method exists in between here. If it finds it, then it will return it. It will execute the method. So in this case, we are expecting an output because it finds. So if we call maybe that, in this case, yes, there A is there is an instance of A, but we are calling now GI. So what will happen in this case is the control flow will go to the class, search it, and see there is no method called GI. If it doesn't find it, it will check for included modules. So in our previous, there was, is it last week, on the last week of the meetup? Oh, it's the other week, last week, but when we were talking of modules and how to include them. So in this case, if the method GI is not in this class, then it will now check if the class A has any included modules. If it doesn't have, it now checks if the class itself, is it inheriting from any class? If it doesn't, in Ruby, if we define a class like this, it inherits from an object. Though we don't explicitly tell it, we don't explicitly inherit, but when we define like this, you'll find that. So like if we do a dot superclass, you'll see its object. So the control flow now will see, yes, it has a superclass, but the superclass is object. So it will go to the object class. Oh, we were doing, it was a hide. It was a.give we were calling. So if it goes to object, actually object usually, if it will go to object, in the object class, you'll find the method is not there. If it's not in the class, it checks if the object includes any module. So usually in the object class, there is the kernel module. I think I can check that in, how can I go to a new okay. Let's check for RubyDoc. So So if I go to, let me check for the object class. Subject. So if you check at the object class, yes, there we have the constants. If you come this side, you're seeing we have an included module kernel. So in our method lookup, in case now this method is not in the object class, it goes to the module kernel. If it's not in the module kernel, checks if the object has a superclass, and the superclass of object that. Oh, let me do a.superclass.superclass. Does that make sense? It will find the superclasses, but it goes here. So usually we have here in the basic object is where usually we have the method missing. So such that if method lookup reaches basic object and doesn't find the method, then the method missing method is the one now called. So in this case, method missing, this error that you usually see undefined method that for that. So this is usually, it's the method missing that actually does this. So this happens because the method lookup reached the basic object and didn't find it. Now it calls the method missing, which now usually gives you this error here. But anyway, okay, so that is basically just what the method lookup is about. So assuming you're the object and someone sends you a message, so you have to figure out how to respond to it, or whether you can even respond to it. So here is a bit of the object streaming consciousness, just how it where am I? Oh, go down. Okay, so assuming I'm a Ruby object, I haven't been sent the message report. So assuming that is like you have maybe an instance of a class, then you're calling report. Then if I have to try to find the method called report in my method lookup path, and if it exists, it resides in a, so report, if it exists, it will either be in a class or it is in a module. Those are the only two places you'll find it. So this is how the lookup will go. So first it checks this report that we want to call. Is it an instance of the class D? So this was, this is just this bit here, where object, this is the object we are talking about, and we instantiated a class D. So now we are calling report. So our first question is this report, is it is it an instance of a class called D? So is the object first an instance of a class called D? So from here you can see that object is an instance of class D. So, does the class D define an instance method report? So if we come to this, you'll see that report is really not in here. Next thing is, does now D mix any modules? If you see the class D, no instance method, no modules, yeah. Then next, does now D has have a superclass? If we check D, yeah, it has a superclass C. So yes, it has a superclass C. Oh, so and now does now the superclass C define a report instance method? So if we see here, if you go to class C, we don't have any method report defined in. So that's a no. Does it mix in any module? Yeah, we have seen include module M, so we are mixing in the module M. And does the M now define the report method? Yeah, so this included module, if we go back to where it was defined, which is here, you can see it has a report method. So yes, it has a report method defined. So if it finds it defined, then now what I should only do is just execute that method. And executing now, that will give you that result. So that's how the method lookup for this one will take place. So the search ends when the method being searched for is found, or with an error condition if it isn't found. So the error condition, as I was just saying, is triggered by a special method called this method missing, which gets called as a last resort for otherwise unmatched messages. So if it goes up like that way until it reaches, it doesn't find it totally, the method missing will be the last thing that will be called, and that error I find will be a trigger of the method missing. So you can override method missing. I define it a new one, either in your new class or your module. So we'll have probably, they're saying that we'll customize our method missing in the next sections. So let's move now from an object stream of consciousness to specifics about the method lookup, and in particular the question of how far it goes. So every object in Ruby is an instance of some class descended from the big class in the sky. Basic object, as in now in the class hierarchy, the super class, yeah, or the last, the ancestor is the basic object. However, many classes and modules it may cross along the way. The search for a method can always go as far as the basic object. So method lookup, yes, will pass the legs of the objects class, and it will go all the way to here, to the basic object. So, but recall that the whole point of now this basic object is that it has few instance methods. I think you can check for, let me check for basic object. So if you see basic object, the methods, yeah, there are few indeed. Here they are. Compared that to, if you compare that to the one in the object, you can see this. Remember, these are defined in the object class. Then there was the module. Let me see. Now, if you see the module, yeah, some whole, really, there are many methods, yeah. Okay, so, but recall that the whole point of basic objects is that it has a few instance methods. So getting to know the basic objects, it doesn't tell you much about the bulk of the methods that all Ruby objects share. So if you want to understand the common behavior and functionality of the Ruby objects, you have to descend from the clouds. So as in from the basic object, just come lower kiasi to the, if you just come lower, you'll find the object rather than the basic object. So more precisely, you have to look at the kernel, a module that object mixes in. So we have just seen that object has an included module, which is kernel. So the kernel, as the name suggests, that it's the kernel that most of the fundamental methods of objects are defined. And because the object mixes in the kernel, all instances of object and all descendants of object have access to the instance methods in kernel. So if you create any instance of object, it will have the instance method that you have included in the kernel plus the instance methods that are defined in the object. So just remember, so if I have object, I can call, let me see if I check for included modules. You can see if I call that, just to check if object has a module, I'll see the kernel. So assume this one, this is a prior way of doing a pretty printing. Okay, but if I was to look at, let me look at basic object. Object that included modules. So, it's included. So in the basic object, you can see we have an empty array, meaning there are no modules in the basic object. But in the object, we find the kernel. Okay. So suppose you are an object and you're trying to find a method to execute based on the message you've received. So like just what we were discussing here, you are an object or you are an instance of a class. Now you want to figure out to execute the this is the message. You are the receiver. So you want to figure out this message that you have sent. You want to search for the method that involves sending this message and execute it. So what will really happen? So that's now this next section. So like we can see, so if you've looked in kernel and basic object and you haven't found it, you're not going to. So like you can, let's see in this flowchart here, we have the class object. Then this is the so object is a basic object. Just the inheritance, so object is a basic object. In the object class, we have the module included. Yeah. Then the class that you define, like for example, in this case, C, it inherits from the object class. Then there was D that also now in this case inherits from C, as you can see by that arrow there. And D includes a module M, and the module of M has these contents here. So when we create an instance of class D and call and send the message to the object, so this is what will happen. So the flow will go to this class. If it doesn't find this method X in this class, it checks if D has any modules. In this case, it's M. It goes to the module, finds if there is if the content or if this method is defined. If it finds it, it will execute. If it doesn't, flow continues. And notice D inherits from C, yeah? So if it doesn't find it, the flow will go to C. Because if it misses it here, I think there was to, if it misses it here, now it goes to the superclass of D. Yeah. Then after here, then it will go to the object. If it misses it in the object instance methods, goes to the model kernel, which is there. If it misses it, goes to the superclass of object, which is basic object. So it's possible to mix modules into the basic object, thus providing all objects with a further potential source of methods. So it's hard to think of a case where you do this though. Yeah. So figure 4.1, which is this, illustrates the method search path from our early example all the way up to the ladder, up to the basic object. So in the example, the search for the method succeeds at module M. So in our case, the search will end up here because our method is here. The figure shows how far the object will look if it didn't find the method there. So if it didn't find it here, it will just go that way until it reaches the basic object. So when the message X is sent to the object, the method search begins, hitting the various classes and mixins as shown with the arrows. So the internal definitions of basic object, and kernel are written in C language. But you can get a reasonable hand on how they interact by looking at a Ruby mockup in their relations. So this is just a way that they are the class basic object, the module of 100 methods. The object inherits from the basic object and includes the kernel module, which is this one here. So notice object is a subclass of basic object. So that we, like you can see in this section here. Object is a subclass of basic objects.
Also, kernel is a module.
Yeah. Oh, I can't hear you get it.
I'm saying so kernel is a module. I thought it was a class.
You thought it was a? Yeah. Kernel is a module, as you can see. When we checked for, let me see. How can we check for? When we defined our class and checked for if the object included a module, we found the kernel. So if you want to know that it's not a module or it's not a class, you can just do this. It's like you are instantiating, though this will, so you can see undefined method. This is like we are instantiating a module which cannot, but if you try basic object .new, you can see you can instantiate it, so that's a class. If you try the object, that's possible, that's a class. We also have a class itself, we can instantiate it. So these are classes. This is a module, we cannot instantiate the kernel. Okay, so as you can see, so object is a subclass of basic object, and every class that doesn't have an explicit superclass is a subclass of object. So when we do class key, yeah. So this is any class that you define without explicitly telling it to explicitly specifying its superclass. This class, its superclass will be object. So if we check for g.superclass object, so that is what this part is saying. Every class that doesn't have an explicit superclass is a subclass of object.
I think it can be hard.
No.
Okay, I have a random question.
Yes.
Like you see when you do in the terminology like class A, then
So I already have a class A.
class.
Okay. Any class.
Yes,
Let's say class D. Then I do that.
yes,
Mm-hmm.
from any other class.
So any other
Yes.
that doesn't exist.
No, it could. Anything.
Oh, let me leave it. Okay.
So when we do this, so does G always have to be the parent, or it could be the parent or the
Does
ancestor? Does this always have to be the superclass, or it could be anything older than the superclass?
does I'm not getting you clearly.
Okay, we have a class D that
Yeah.
inherits from G, right?
Yeah.
So does G always have to be the parent or the superclass of class D, or it could be the superclass of the superclass?
Oh, so I think actually we can try this out. So it's like you're asking if G has to be like an immediate superclass. Yeah, an immediate superclass. So let me just control Z. Mhm. So assuming I have a class A, and I have a class B that inherits from A. Then I have now a class C that inherits from oh
B.
that inherits from B. Mm, okay. And
So now we should have class C,
class.
C inheriting from class.
Oh, we already have C.
Oh,
There'll be a superclass mismatch. So though I'm getting your, I want to see how we can. Oh, okay. Let me just use this side. So we have a class A. B inherits from A. We have a class C. C inherits from B. Then we have a class E, but in this case inherits from B. As in, it doesn't inherit from C. So if you were like to, so like this. So this is like if I was to draw the, it's like E. Let me just write it. It's like we have E and we have B. Then we have, oh, actually we have C. Okay, let me start the other way around. The super. A is the super, yeah. Then there is B. After B, we have we now have C. And then E. But not if we'll be, if we draw it like this, it means E is C is a superclass of E, which is not the case. So probably, if we'll be drawing this means,
it makes sense.
yeah.
It makes sense because E is the subclass of C. Then C is the subclass of B. And B is the subclass of A. Right. So my question was, if at all we had E, right?
Yeah.
Then we say that E inherits from B. It will be the same as us saying E inherits from C or E inherits from D.
Oh, so if we say E inherits from B, so meaning this will come here actually to the class B. If we say E inherits from B, if method lookup, if we were searching for, if we create an instance of E and we tell it its superclass is B, it will now come to where the class B is. It finds that the class B is a subclass of A. So maybe if it was missing here, then it will now go to the class A. Are you clear? Is it answer? Okay. Okay, so every class has an object, and therefore the kernel and basic objects among its ancestors. Oh, every class has an object, and therefore kernel and so if I do so if I check for, let me say or let me just do object ancestors. We're expecting to see kernel and the basic object. So we have the kernel there and the basic object as the ancestors. Actually, this here is usually, this order actually here is just actually how the method lookup will go. Assuming this, it's a prior thing, yeah. So this what will happen in the method lookup actually, if you defined a method, maybe in the, it will start with the object class. If it's not there, checks for the kernel module. After that, if it misses it there, then it will go there. So these are the object ancestors, as in the method lookup after, yeah, from the object class itself. Okay, so of course there's still the paradox that basic object is an object, and object is a class, and a class is an object. Yeah. How basic object is an object. Yeah. We can start. Okay. But as you saw earlier, a bit of circularity in the class model serves to jumpstart the hierarchy, and once set in motion, it operates logically and cleanly. So I think, yeah, from this section, I think from now we have understood the method lookup through the class hierarchy and how it goes up to the basic object. Okay. Yeah. I'll get you what you're saying something.
I was saying that we should do a recap and then start from 4.2.2 next.
Okay. Okay, I think oh, we have 5 minutes. So next, I think next we'll begin from here. I think this section, there's a lot to sink in. So next mob will begin from defining the same method more than once and see how that goes. Okay, thanks guys. This has been our mob for today. Till next time.
Bye.
Bye bye.